Today we're going to be talking about the enthalpy of a chemical reaction and how we can calculate that. When we look at the change in enthalpy of a reaction, we give that symbol a delta H, that delta triangle in front of any symbol in chemistry means change in. And we can use this equation to calculate that change. Now this symbol right here is a sigma. It stands for the sum of adding up all of what are called the heats of formation of the products. We add up all of the heats of formation of the products and we subtract off the sum of all of the heats of formation of the reactants. So that seems a little bit complicated. Generally, what I usually write is just that delta H is equal to the sum of the products minus the sum of the reactants. That's how I write it by hand. Now, what do we mean by heats of formation? Well, there's a table that you have, and that table looks like this, and it's a set of selected thermodynamic values at standard temperature for thermo, which is 298 kelvins. The column that we are going to be interested in is this one, the heats of formation. And this is the amount of energy involved when a mole of a compound is formed from its elements. So you get all kinds of different values from the amount of energy that's involved. What you have to be careful about, notice all these zeros, and you'll start noticing a pattern for all of these zeros. They're for all of our elements in their standard state, whether it's a metal like aluminum or a non-metal, even if it's diatomic, its standard state is Br2, and all of those have a heat of formation of 0. You can't form an element from its elements. That doesn't make any sense. So they don't have a heat of formation. Their heat of formation is 0. So let's go back and look at um, our notes at the front page, and we see that the heat of formation is defined here, what I just said. So when you need to define that, you can find it. This is the statement I just made about the heat of formation of an element in its free state being 0. Another thing that we need to keep in mind is that exothermic reactions are said to be thermodynamically favored. We used to say spontaneous. We're not saying that very much anymore. They're starting to get that kind of slowly but surely omitted from AP language. Endothermic reactions are said to be thermodynamically unfavored. We have to put energy into those systems to get them to react. So that's something that you need to remember. So on this first problem, it says to calculate the enthalpy change for the following reaction and determine whether it's endothermic or exothermic, and determine whether it's thermodynamically favored. Now remember, exothermic reactions are negative for their delta H values, and endothermic reactions are positive. So we're going to be able to tell whether they're endothermic or exothermic simply by the sign when we get the answer. Okay, so we need, first of all, CH4. Let's go back to our table, and we see that CH4 is down here, and the value for CH4 for its heat of formation is negative 74.81, and you can see at the top of the table the units are kilojoules per mole. Now we're going to remember the kilojoules per mole at the end, but I don't write those down every single time because it kind of gets in the way of the numbers sometimes. So negative 74.81 is going to go here for CH4, and there's only 1 mole of that. Now look at how this one is balanced, and this often happens on our thermodynamic equations. We've got 3/2 of an O2 when we balance this, and that's because in thermodynamic equations we virtually always want them to start with 1 mole of the reactants, to have the reactants based on 1 mole of the smallest substance. So that's why we have 3/2 of a mole of oxygen here. So we've got negative 74.81. We need oxygen's value But if you remember, since oxygen is a free element in its standard state, diatomic oxygen, the heat of formation is 0. Water. Watch out for water. Look back at our table over here, and I've got it marked. Notice there are 2 waters. We have to be very careful which one we want. And if you look back at your notes real quick, you'll see that the water in this equation is a liquid. So we want to make sure and use the correct one and not the one that is a gas. So the water value that we want is the negative 285.8. Let's go back and put up our negative 285.8. Now notice something else. This is kilojoules per mole, and notice we've got a 2 in front here, so what we're going to have to do with this is multiply this by 2. If there's a 6 in front, we multiply it by 6. If there's a 4 in front, we multiply by 4, so watch for that. Finally, the last one is carbon monoxide, CO gas. Let's look at our table. You have a front and back. I put them all on this one, but if you look down here, you'll see carbon monoxide gas is negative 110.5. So let's go back and fill that final one in, negative 110.5. And this is how I want you to set up this problem. The first thing I want you to do is to write the equation. And remember, if it's in red or blue and you don't do it, you're going to lose points. So the heat of reaction is equal to the sum of the products minus the sum of the reactants. And I want you to write those down. That means the heat of reaction is going to be equal to 2 times the H2O plus 1 times the CO. So there's going to be our products minus our reactants. And the reactants are 1CH4 and 3/2 of an oxygen. Once you do that, then I want you to fill those values in. So our next step is to say that this is 2 times our negative 285.8 plus the negative 110.5 for the carbon monoxide minus the negative 74.81 plus 3/2 times 0 for the oxygen. Now, if I don't see that step with those numbers filled in, it's going to count you points off. So I have to have the equation, have to have the substances involved, have to have where the values are substituted in. In the next step, I want you to write what it comes out to when you actually multiply and add through this. Remember, you can put this straight into your calculator as 2 times negative 285.8 plus a negative 110.5. If you do that and then hit enter at the end, you'll get negative 682.1 for this answer. And we're going to subtract off. And when you plug this in, obviously when you plug in this value, 3/2, 3 divided by 2 times 0, you get 0. So that's going to drop out and we'll have negative 74.81 here. Do not take shortcuts. If you take shortcuts, you're going to mess up this minus minus here at the end. This gets my AP students even every time if you're not careful. So now we can plug this straight into our calculator, negative 682.1 minus a negative 74.81, and we get negative 607.29. Since the least number of places past the decimal in my problems, there's 2 places past the decimal here, 1 place past the decimal here, 1 place past the decimal here, which is what I have to go by when substances are being added or subtracted. My answer can only be 1 place past the decimal. So this becomes negative 607.3 kilojoules per mole. And we always write kilojoules per mole reaction, which means this is how many kilojoules of heat are involved for the reaction as written up here. because if they balance it any differently, that would change. But as written, this is what we would get for our answer. For instance, if they balanced it by multiplying through, we get rid of that 3/2, so we have to be careful. Okay, so once I've got that, that's not the final answer. Remember, it wanted to know whether it was endothermic or exothermic. Well, since it's negative, that means this is an exothermic reaction. And if it's an exothermic reaction, go back up to the top of your notes. Exothermic reactions are thermodynamically favored. And AP, we add some more to this and start talking about the disorder of the system and how that also affects reactions. But at Chem 1 level, we just want to look at the enthalpy of the system. So this is exothermic, thermodynamically favored. Just keep in mind that if you end up with a positive delta H, this is going to be endothermic, and it's going to be thermodynamically unfavored. And you will come across that in your worksheet. So make sure you're paying attention to that sign.